All right. Good morning. How are you doing? All right. Our next topic, remember that our last topic was on the scaling. Our last topic was on scaling. So I'm trying to see the activities of that class before I proceed with uh, to this topic. Unfortunately, it's like I don't have it on my notebook. Probably this is not the notebook. So, however, we are diving into a new topic actually, which is called clustering. So, we are looking at clustering. That is the topic. Clustering. So, in data science or in unsupervised learning, what is clustering? So it's actually a wide topic. So what I'm going to do, I'm going to be breaking the recording into section. Then you take your time to watch them serially for you to understand it. It's a very broad topic and it's very interesting. It's a bit logical, but it's worth learning. So let me quickly look at the highlights, what we shall be focusing on in this section. So in this section, in this section, in this section, we will introduce the fundamentals of clustering, and compare three popular clustering techniques. Three popular clustering techniques. So that is what we shall be focusing on. So we have three techniques that we use in clustering in Python, and we shall be focusing on them. So what are these popular techniques? We have the K-mean. We have what we call the K-means clustering. So this stands as types of clustering. So we also have the hierarchical hierarchical. Very sure if I'm correct. I think I'm correct with this spelling. Hierarchical clustering. And then we also look at, let's say, and what? We'll also look at DB scan, DB scan, DB scan. So all these are techniques which are used in data clustering, in data science. So we have just read some of this because of time, so you can take your time to document them. And I would advise you to document all the possible notes to make you to have a good background on what this topic is all about. Okay, so I said in this session, we'll be introducing fundamentals of clustering and compare three popular clustering. So why, when we use the word popular, we are not talking about these are the only clustering techniques, but these are the popularly used clustering what techniques. So what we are expected to cover within this topic. So this topic will cover topics we will talk about, like I've mentioned about clustering. We also theory model, K-means clustering, about the DB, about the DB aspects we shall cover for this topic. What is our goals? So learning. So we will also apply different methods to have the right picture, so that when we start achieve. So also interview, compare and contrast the popular clustering techniques. Just want you to have these notes about learning. The first is clustering. So that is a topic, though it was personal. But the concept is very simple, as in if we are to relate it to a real life situation, very simple. Only that the logic are a bit complex. But like I said, as I break them down bit by bit, so I cannot give you a straight video on it because it's broad. So I'll be breaking it down at least within 3 classes, 3 recording. I must have concluded it. So let's look at the definition of what we are talking about. So what is clustering proper? What is clustering? What is clustering? So here I will start defining. I only note that the key things I want you to know, but please, most of my definition, make sure you jot them down. They will help you. So let's define clustering. So clustering allow you to find concentration. Concentration. So the key word here is concentration. That is, you can have a lot of value and then you want to concentrate on some. So this is good from the name clustering. It's like you are grouping. Remember, that is what unsupervised learning is all about. It's all about what? Segmenting, grouping data for better what? Modeling. Now, when we say clustering, you are like you have different data sets, like different categorical data. For example, one of the popular data we have been using, that Yagon's data or the salary payroll, where you have record from Yagon, you have record from 3 different cities, if I could remember, Mandalay and the other city like that. Now, in a situation whereby you want to cluster you want to group this record according to the distance. According to the distance, that is clustering. According to the distance. For example, now, if I have item, let me see if I can use my pen to explain some of this. So let's say you have, let's assume you have, this is what we are talking about. Let's say we have this. So this is just like a graph. This is just like a graph. We have something like this. Then we have another group here. This is clustering now. All these are clustered. That is what I'm illustrating now. So there is a factor that determines how you group this one different from this. We use a factor called what? Distance base. That is what? How they are, distance from one another. So the ones that are very close to each other, those ones are clustered in a group. And each of them will be tied to, as we implement it live in Python. So we have some sets that we will label this. We have a cluster of different names. Okay. So the idea is that you have a graph like this. I'm trying to visualize it, but these are some theoretical things you need to understand. And then remember that the graph will have a scale. The graph will have a scale. So this is what mean by the clustering. This is the clustering. Don't mind my writing. So this is the clustering we are talking about. So that is why I say clustering means what? Finding concentration or groups of concentration which are similar to one another but distinct from other groups. For example, what I did here now, all these ones that are clustered here, that are grouped here, they are similar to themselves. So in a data set, all the records that come from Yangon City, they are going to be clustered. They're going to form a cluster. You know that one? Why? Because they are similar to themselves. All the records from Mandalay will also be what? Clustered. Why? Because they are also what? Similar to themselves. So in a real life experience in a company, when you collect customer record as a data analyst, when you are drawing insight or a data scientist, you are going to be clustering those customers' record. That is, you are going to be grouping them. That is the idea. And the reason is that such that when you want to assess some, you can easily what? Assess them. So there is a target to the reason why you are clustering your report. So I just cited that life scenario so that you know where exactly we are driving to. So you can have a whole lot of customer data given to you as a data scientist, and then you are asked to perform what? Clustering analysis on them. That is what you are to group them according to their similarity. The similarity might be the location, maybe the ones in Lagos. So there are different factors we use in identifying what this similarity that will eventually lead to what? Clustering them. So I just believe you understand the concept. I'm just trying to make sure that you know what we mean by what? Clustering. Simple terms in now. Remember I say what? Clustering will allow you to find concentration. Now that I have clustered this now, I have grouped this set. I have grouped this set. This can be product A. This can be product B clustering. And this can be product C clustering. So now that I have clustered them, I can now easily focus on them. That is what we are saying. To allow you to find concentration or groups of what? Concentration, which are similar to one another, but distinct from other what? Groups. So this group is different from this group. This group is different from this group as well. So that is the idea behind what? The clustering. So just to explain further, I said, if you look at the above scale, above scatter plot, so this is the scatter plot. If you look at the above scatter plot, you could see the group of data. Therefore, what clustering allow you to do is to mathematically identify these three as clustered as different groups with different word clustering within the data sets. But visually, as a human, it is easy for me to identify, but how can the computer do this? You see, it is very easy for me as human to understand this clustering. But how can the computer know this? How can the computer assemble this? It's very simple as human being. But for the computer to be able to be given a data set and be able to cluster the record, that is where the work is. And that is what brought about this clustering. So we are going to be leveraging on some Python library. There are a lot of libraries we are introducing here that we have never heard of, which we are going to use to ensure that we are able to cluster our data sets. So Python is going to do that with the help of library. So it will have to use machine learning. So for the computer to be able to cluster, just like I have on the screen now, it will have to use what? Machine learning with specifically a clustering techniques. Specifically a clustering techniques. Okay? So I hope that is understood. I want to quickly move on. So here we want to talk about the words clustering. I want to talk about the clustering workflow. Clustering workflow. Clustering workflow. The general clustering workflow consists of the following steps. I will say workflow, we don't know what? The procedures that are involved for you to be able to work successfully cluster your record or your data. So number one, you can think of a high level. You can think of a high level generic workflow for any data science project where the clustering workflow is more specialized. So these are just some facts. So the workflow is this. I'm going to use diagram to explain it very well to you. So the way it works is that you get your data. So let's say you have data preparation. We have data preparation, then followed by modeling. Followed by modeling. So under data preparation, you get your data ready. Under this, you get your data ready to be imputed into a machine learning model, a machine learning model, a machine learning what? Model. So you get your data ready to be imputed here. Then under here, you apply a clustering algorithm. Here, you are applying what? Clustering algorithm. That is what you are applying here. Clustering algorithm. So such as it is from here, you now have those techniques that I mentioned before, like the k-mean. So this is where you have the k-mean. There you have the k-mean clustering. This is where you have the hierarchical clustering. This is where you have DB scan. So you can see it now. You pass your data into the machine because you are training it, and then into the model, and then from there you start applying the techniques. So that is one of the steps that will be involved. Then you also single table. You're going to need what? A single table with what? Non-null and numerical what? Data. So you can see it's one of the reasons why all this why we have been doing what we call row regularization or row what? Regularity, that we have been working on, trying to remove, trying to delete some column and the rest of that from the data sets. All of that is so that we can able to pass it into what? A model that can be used for what? Clustering. So you are going to also do what we call feature engineering. Thank God we have done feature engineering. Remember, the word feature means the headers, where we talk about what? Under feature engineering, selection, and what? Scaling. So under the procedure, the workflow, you are going to get data, pass the data into model. Into the model, you apply these techniques, hierarchical, k-means, DB scan to achieve that, like I said, and then it's going to also involve engineering, there is going to also involve tuning the data. That is what? Under tuning, that is where you'll be selecting. You are fine tuning. At some point, you are going to be removing. So under tuning your data, you are going to be evaluating and tune model using metric and what? Intuition. Intuition. That is what you're going to be perfecting. You're going to be, you know, fine tuning the data. The under selection, you're going to be picking the best results and identify any insight. Okay? Then all these are steps that are involved. So in summary, data preparation, modeling, then tuning or selection. So in summary, we can summarize the whole workflow of clustering into what? This. So we are going to have at the end of the day, data prep. We're going to have data prep. Then we have modeling. Just make sure you write them in full. And then we will have tuning. Tuning is where you are fine-tuning the data. We're going to have tuning. And then we are going to have selection. So this is we are going to have selection. So you can see the step now, data preparation, that's where you supply the data. Then to the model, you work on it, you remove what is not needed, that is you are fine-tuning it, and then here you are picking the best results that is best applied to the challenge you are trying to solve. So remember, there is no specific order that says that sometimes you can start with this, that is from data preparation to what? To modeling, and then from modeling to what? To tuning, from tuning to what? To selection. You can sometimes, there is no order. This can be your 1, this can be your 3, this can be your 4, and then this can be your 5. Based on how you are getting the results, then this can be your 1, this can be your 2, this can be your 3. So there is no specific order. So I want us to take that as a note that well, clustering is not just about the data anymore. It is about what makes sense and can help you solve your problem. So that should be your primary objective. So that is the reason why I'm saying that this order 1, 2, 3, 4, 5 may not be followed. If the order that need to solve your problem is data preparation, modeling, then you go to selection, you go ahead with it. If the option is data preparation, then tuning and selection, go ahead. So the entire process is not a linear process. So you can see it's not 1, 2, 3. So it can be zigzag, it can change. So bear that in mind. At times, you have to go back and front. So when you are doing this, so remember, there is no right answer or single optimization metric when it comes to clustering. The best output are the ones which helps you answer your question at hand and make practical data-driven business what decision. So there is no right answer. The best one is one that helps you to solve your business what that have to solve, have to answer the question. Yes. All right. So I said what? remember, there is no right answer or single optimization metric when it comes to clustering. The best outputs are the ones which helps you answer the question at hand and make practical data-driven business decisions. So clustering algorithm is the next thing I want to talk about. Clustering algorithm. So here we are going to be looking at those techniques. Clustering algorithm. Clustering algorithm. So the first one is the K-mean. The K-means clustering. The K-mean what? Clustering. It is one of the popular clustering algorithm. It is one of the popular clustering algorithm. The K-mean. So let's quickly look at the definition of this K-mean. K-means. Let's look at the definition. So we have already started discussing the techniques now. Let's look at the definition of it. So the K-means clustering. The K-mean clustering, like I've earlier defined, is the popular algorithm. It's a popular algorithm which assigns each observations in a data set to specific cluster. Once it's observed, it will assign then to what? A group. That's the meaning. Where the letter K represents the number of clusters in the data set. So that is what happened. So you can see the concept now that is a popular algorithm which assign each observation in a data set to specific cluster, where K represents what? The numbers of clusters. So what I explained the other time is what we are talking about. So let me just use the diagram to explain that again. I want to make sure that you are picturing where we are going, because when you start seeing Python, getting all this value easily with its own library, then you know what is happening at the background. That is what I'm trying to picture all this. So this is just like what we are talking about. The graph. So once you give this is your data set now. You give it to Python. So with the help of the k-mean concept, remember I said what? There are popular techniques which we use in clustering data in Python. One is k-mean, and that is the one we're talking about. So this one uses, this one observe your data. This one study your data and identify what data record that are familiar and what assign them to what groups, which are now called the cluster. So what we are saying is that we have all this, not like the diagram I gave to us before. So in your note where you are writing all these diagrams, please, I want you to sketch them, because looking at them will help you to understand. So this is assumed to be a data set given to Python, and then using the k-mean algorithm, it's able to what? To observe the entire data set and group them. And what? Group them. So this group, they are the cluster. This could be what? Clustered what? This could be clustered A, based on their familiarity. This could also be what? Clustered B, also based on their similarity. So here is how it works. So how does it work? So I don't know if I'm just how it work. How it work, we are trying to explain how the function will be implemented in order to what? To cluster what you are seeing on the screen. So all these are very important. All these are very important. So how it works. How it works is that number one, it's to select the k. Remember I said the k is what? The numbers of what? Clustering in the data set. So in this case now, how many clusters do we have? 2. Okay, because of time, let me just read through this, but make sure you note them. How it works, number one, select k arbitrary location in a scatter plot as cluster centers or centroids, and assign each observation to a cluster based on the closest centroid, based on the closest centroid. So what does that mean? That record based, I mentioned before, so it's going to cluster, it's going to be grouping this based on how they are close to themselves in the location. That is the similarity. So that is a concept. So what it's going to do is that it's going to assign a center or a centroid. So for example, now it will assign that, okay, let's say this bigger one is the centroid here, and this is another word, centroid within this location. So all the values that are here that are similar will be what? Attracted to this center. All the ones here will be attracted to this center. So that is what I mean by what? Select k arbitrary locations in a scatter plot as cluster centers or centroid, and assign each observation to a cluster based on the closest what? Centroid. A typical example, if you want to maybe group certain people in a particular location, let's say Delta State. Let's say there are some palliative the government want to share, and they want to look at the clustered, how they want to group all the people in a particular region in some location, just like when they were doing a voting. So you can see that they adopt that system. When they were doing, you check INEC now. INEC have different clusters. These clusters are the polling units. So they look at the people in a particular area and group them and tag them maybe what? Particular units. And then look for another one again and group them, so that when they distribute their material to these various locations, people in those locations will be able to access the what? The what is it called? The voting register, and be able to vote. But in this case now, what we are relating to what? To data. So data that has been collected. So the Python, with the help of this algorithm, can scan through the data and observe some to be clustered in a particular group, an order to be in another group. That is what we are saying. So this is how it's going to work. You're going to be selecting the location, and then we're attracting data that are similar to that location. Then number two is going to recalculate and relocate each centroid. It's going to, after grouping them, it's going to calculate and relocate each centroid to the mean, that is the average, of the observation assigned to it. Then reassign each observation to its new closest what? Centroid. So at first, it will what? Group them. Then and now start calculating based on what the similarity, and now reassigning to the right place where they ought to be. So it's a very simple logic. I just hope you are following. Just give me 1 minute. Right? So that was the step 2, how it works. Don't forget, I said it will recalculate and relocate each centroid to the mean of the observation assigned to it. Then reassign observation to it. So new closest to new what? Closest centroid. So it's going to be doing the calculation based on the distance. At first, it will just what? Group them. That's the K-mean now, K-mean algorithm. Remember I said we have the K-mean algorithm, we have the hierarchical, we have the DB scan. But right now we are focusing on the K-mean concept. How does K-mean perform its own clustering? And that is what we are focusing on. I want you to get it. So number 3, repeat the process until observation no longer change clusters. So once it has assigned them to different center or centroid, after the recalculation, then it will now reprocess it. It will repeat the process until no one is qualified, until no more what? No more changes. That is when it will say, okay, this is the workable model. Okay, so let's look at the applications. Let's quickly look at the applications. Applications, so you know, in the real lifetime, where can this clustering concept be applied? Application of K-mean application of K-mean use case. Application of what? K-mean what? Use case. So the first one is what? Identifying customer segments. So this is, I'm bringing it to business now. Identifying customer segments. So when you are given data sets that comprises the collection of different customer records in that data frame, so you are going to what? Identify customer, you're going to what? Group them based on location, based on the type of product device. So there are different criteria you're going to use. So when you are grouping them in the organization like that, when you are identifying this customer according to the location, maybe the one from Lagos, the one from Delta, you are already performing what? Clustering. That's exactly what we want to do here now. Like I said, by saying it is very easy as human, but how can Python be able to do it? How would the computer? That is why we are training the model, we are training the system to begin to act as human being in a way that when we give it data, it can do this segmentation for us. And how it's going to do, it's going to leverage on these techniques, K-mean algorithm, hierarchical, and what DB scan. And right now we are focusing on how does K-means perform its own work clustering. Identifying customer segments for targeted marketing campaigns. So in a company that want to run vigorous words campaign, would sit down and segment the customer so that they can know where to market their products to them. All these things happens in our various working place. But we are saying that how does Python does that? Because these are the things that will enhance prediction. So number 2, clustering stores locations based on factors like say. So in other words, I'm not suggesting that in that scenario, you're going to be what? Storing, you're going to be clustering stores location based on what? factors like sales, rating, size, and etc. So let's say you are, let's say you, you have a bunch of customers, you put them all into scale, let's say scatter plot, and you find out different types of customer based on their behavior and put them into different what cluster rooms or segment them, and then you can then know your targets. So I'm just trying to picture this. You have a bunch of customers, and then you now what? You now scale them, maybe with scatter plots, and then you find out different types of customer based on their behavior, and then put them into what different cluster rooms or segments. Then you can know your targets. So I just try to align this, bringing it to real life situation so that you know what this entire clustering is all about. I hope you are following. So we are going to be looking at the steps, K-mean clustering steps. Number one, determine what you think might be an appropriate, determine what you think might be an appropriate number of clusters. So you're going to find out how many clusters, well, you are given data now, okay, how many division, how many segments you can divide it into is one of the steps we are going to do. So we are going to first of all what use the K-mean with the help of other word transformating or calculation. Just a minute. All right, so your number one step, I think let me highlight all these steps. It's very important. I highlight them. Very important. So steps. So once you understand all these steps are the practical steps we are going to involve in. So please pay attention to them. Make sure you note them down. So our first step is going to be determine what you think might be an appropriate number. Remember, I told you that the K represents what? Number of clusters. So we are going to do that. So, but in this case, we are going, in this case, select arbitrary location as initial centroid. So just to highlight, until we start applying the steps, you may not understand them very well, but let me just highlight them. So step number 2 is going to be, once we have determined the number of clusters we could have in the data sets, or how many of them, you can decide. Actually, there is an attribute that will help you to say, okay, you want everything to be in 2 clusters, you want everything to be what? In 3 clusters, and so on. So it's your choice, depending on which one will help you to narrow down to what you are looking for. So assign each observation. Assign each observation. So that will be our next step. To a cluster. to be clustered, and that is going to be based on the closest, closest centroid. So what we are saying is this could be the data in y-axis and what s-axis. You can just have them scattered anyhow. We'll have them scattered anyhow. We'll have them scattered anyhow. Because this clustering has not taken place here. That is why they are all scattered. So at the end of the day now, we will now have the k-mean. We look at this data and find out the one that create different centroid or different clusters. So I can say, okay, these are the centroid. Then after this, it will now start picking some and start arranging them around that centroid. So that is what it's going to do. All this is Python that will be doing that for us with the help of functions. So what I'm doing, I'm just trying to give us the theoretical background, because at times you might be asked to explain how it works, other than just knowing how to use the library to implement it in Python. Okay, so that is what we're talking about. So the data is passed into the model like this, and then once we implement the k-mean, and then it will now what? Segment them. Okay, so I believe that is clear. So your step three is going to be relocate each central. Relocate each central to the mean. So we're going to calculate the mean. So it is that mean base that they will be relocated. Mean of each assigned observation. Assign observations and reassign each observation. Each observation to the new closest central. So we have highlighted 3 steps so far, 3 steps. The first one, you are going to determine how many clusters do you want. You say 5 to give you, if I say 3, we'll give you 3. Then you also assign each observation to those clusters, and then you now start relocating. So that is what, like I said, all this will be done for us by Python. We are not doing it, but this is what you need to know. This is what you need to know. So I have some graph here that I'm going to use to explain all these steps, which I'm going to use to explain all these steps. Let me see. So I have this one. This one is not relocated. So this graph is telling us at the point where you have not relocated the data. So you have like this, then we have something like this. Then we have different values under them. We have, so that is just like central. So we have something like this. So there are different types. So this one with triangle, they are different value. The one with cycle, they are different value. or they are still together, not relocated yet. So we have another, maybe another central somewhere here. Then we have more of the triangle shape. So this triangle represents one entity, while the cycle represents another data or another record. So you can see here you have some of this record mixed with the other one. They have not been relocated. Now, we have another graph where we have relocated. Now we have separated. So we have here we have all the cycles. So Python is the one that will have used this K-main system. And then you now have all the ones with rectangle, with triangle. You can see what we are saying now. So this is clustering, perfect one. Look at them here, they were all mixed up. So you can see the reason why we are having these ones here. We are having this one because if you check these ones, we have more of the circular objects here. Then we have more of the triangular objects here. So now that as we are segmenting, so Python has observed that based on the distance between those similar ones, so it has grouped them here and grouped this one what somewhere here. Sorry, and group this somewhere here. Okay, so here now they have been relocated. So, like I said, it will continue until it finds out that what no more changes before it will stop. So that is all about what K-mean clustering. So in our next class, so this session is just to give you a pictorial representation of how we are going to use the K-mean algorithm to be able to what? To cluster our data set. So our next class is going to be the practical aspect of it, where we will now start applying it. This is how you are to learn it. You must understand the theory. So everything I've done now is the theory of K-mean, okay? Or is the theory of clustered data clustering and the algorithm. And remember, out of all the techniques or the algorithm, I have only spoken about one, which is what K-mean. So what I'm going to do in my next recording is to see how I can practically, using a live data set, to implement that K-mean and be able to identify all this that I have talked about, the centroid, the mean, and then after that, I will also come with the theory of the hierarchy or the DB scan and also implement it. That's why I said it's a very broad topic. If you look at my introductory statement, I say what? When we talk about unsupervised, is one of the topics that cannot be avoided. You cannot avoid the clustering concepts. You cannot avoid it. So it's very important. So I don't want us to run through it as a stretch. I want to be breaking it down bit by bit, the theory aspect of it, so that when you get to the practical, you know what the functions are doing for you. And so that you can interpret it, because at the end of all this, you are going to write your interpretation, and that is what will guide in decision making. So I believe this session, uh, you understand everything that I have explained. Thank you. So take your time to listen to it. Make sure you digest it, you understand it, please. So that anytime I ask you what is clustering in data science under unsupervised machine learning, you should be able to what? To reply. Thank you.